Well, hi and welcome to my shop here a little late on January 13th. It's a bit of a late start for me today because I've spent a fair bit of time studying information about this radio. So the situation here is the oscillator circuit, the local oscillator circuit, will not oscillate on the two highest bands. The reason for that, I don't know. I've checked all the basic things and everything appears to be fine. So what am I left with now? Well, what am I going to do next? So I've restudied all the information looking for hints or anything that I may have missed about this radio, and in fact there was a statement that I'd forgotten about. There's a statement in the manual that says if you are using a particular kind of test equipment, I think it's called an analyst, which is basically a shop in a box, a shop full of test equipment in a box. The long leads, I guess it's the long leads or the leads coming from that piece of test equipment, may prevent this from oscillating or may cause it to oscillate when it shouldn't. So what's that saying? So that's basically a warning saying, hey, things are a little precarious with this radio. So if you don't have oscillations, maybe it's your test equipment. Maybe it's, oh, okay. So causing a local oscillator to fail to oscillate by hooking up test equipment, not something I've really run into. Suggests to me in most radios the local oscillator is pretty strong. This is an older radio. I guess it's just a case that, you know, in the history of radio development, at this point, sorry about that, I have my phone too close here to the microphone. At this point in radio history, the local oscillator circuits are still precarious. There's another warning in there about lead dress. As much as the wires in here just seem to be kind of any old place, they just seem to be running through space in a kind of a random way. Like, look at this red one. It's just kind of shooting over here. It's, you know, is this even the proper way for this wire? Can this one? These are the oscillator coils. Can a wire like this affect this over here? There is a yellow wire. Let me see if I can get it on. Here it is. Here. So this is coming from the oscillator tube, and it's going a long distance. Well, not really. What am I saying? It's going up. It's going up back in here where my finger is, and you can't see it. And it's laid up tight against a steel support rod, one of these steel support rods. Is that the problem? Did it just pull it away when it suddenly start oscillating? I don't know. So I think what I want to do to pursue this a little bit further is look at the oscillator strength as I go through the bands. I suspect that even the last highest band that's operating, the oscillator is already getting weak on it. It sounded that way to me when I was tuning it. I could hear the effect of the tuning, but it wasn't very distinct. So one of the suspicious components in here actually is this capacitor right here. All the time the oscillations pass through this capacitor, no matter what band you're on. Well, I hope that's true. But what I did in this case, actually you can see the green wire going up to one of the two grid caps. So the signal's always on this capacitor. I paralleled this capacitor with another one of the same value, I think 110 picofarads, paralleled it in there, it made no difference. But maybe I didn't pursue that as thoroughly as I could have. So what I'm thinking here is a good place to measure the signal, oscillator signal strength, is on either side of this capacitor. We'll look at this on the schematic in a minute. So where the oscillator is strong, I could read it on this side, see the strength, and then read it on the other side, and maybe see it's reduced. Maybe that'll implicate this capacitor more directly than it has so far. That's my thinking. Now another observation here, I may have misspoken. I regularly say things wrong in these videos, you know, it's just me talking off the top of my head. And also inside my head, when I'm talking about this stuff, I'm constantly registering how important it is. So I may make an observation early on in dealing with the radio, and I may say something about it. You know, this wire does that, and I'm totally wrong. But I also know it doesn't even matter if I'm wrong, so I don't care. So I'm just saying stuff and moving on. It's just a casual approach. It's just me talking out loud as I'm thinking. So if you think I'm careful about what I'm saying, I'm not. It's just whatever is in my head coming along and coming out. And sometimes, just to go a little further on this theme, sometimes what is in my head is not what's coming out of my mouth. So in my head I might have blue and red will come out of my mouth. And this happens to everybody. It's just, unless you're involved in a live recording situation, you'll never know you did that. I'll go one step further. Some of you have heard me say this. There was a typical standard marital argument I had with my wife for years, in which she would say, Jim, you said we have to go at 2 o'clock. And I'd say, no, I didn't. I didn't say that. I said 4 o'clock. No, you said 2 o'clock. Why would I say 2 o'clock? I know it's 4 o'clock. There's no reason why I would say 2 o'clock. I must have said 4 o'clock. And then that would be the end of the argument. Today, when my wife says, Jim, you said 2 o'clock, I say, oh, I'm sorry. I meant to say 4 o'clock. Because now I realize that even though I think very firmly I could not have said 2 o'clock, I probably did without realizing it. So there's a lesson to all of us. I've learned it. Let's all learn it. Now, so my thinking here, again, getting back to the radio. I was just about to comment on this. So the radio has a message built into it that it has trouble oscillating on the higher frequencies. And that message is this coil here. I've mentioned this a couple times. Let's just look a little closer at it. Oh yeah, and I also mentioned, I started saying I misspoke before. I think I mentioned that these would be the higher frequency coils. No, I got it totally backwards. More coil, more impedance, designed for a lower frequency to generate the impedance necessary. So lower frequency, more coil. High frequency, less coil. But this has only got 3 turns. But if you look very closely at this one, there's another set of wires in there, very, very thin wire in there, connected to these terminals, and there's wires going right back to the oscillator tube. So at all times, no matter what the oscillator, no matter what band you're on, the oscillator's oscillations are present in this coil, and they're closely coupled to the regular winding in this coil for the highest band. So that's telling me this thing needs a lot of feedback in order to oscillate, and to the point where on the highest band they've had to do this. And I think there's a chance that what's happening in this, let's call it a tickler coil, feedback coil, is it's also influencing this one. They're so close together. So is it possible that there's just no signal arriving in here, and so there is no feedback, and so this coil has no hope, this circuit or band has no hope of oscillating? This one, maybe, but it doesn't. This one's still working weakly, because look at how far it is now from this. Is that what they did here? I don't know. But for sure, they put this winding in for the highest band. So all indications are this is a troublesome guy to make oscillate at high frequencies, and that's the trouble I'm having. So I think what I want to do now is get the radio operating, get onto a band where the oscillator is going, try to measure the level of the oscillator, maybe use the scope. It's kind of a visual way of doing this. And then just poke around a little bit, change bands, poke around a little more, change bands, poke around a little more. That'll be the 3 operating bands. And just see, just try to get a little more information in my head here on what's happening. It basically, I think it has to amount to the idea that there isn't sufficient feedback in the oscillator circuit to trigger the oscillations. Why the insufficient feedback? Don't know yet. That's the whole deal. So I'm going to stop and crank up the radio, and then we'll carry on with it operating. Okay, I think we're ready to start, so I'll be listening with the headphones to... Oh, I can already hear the radio. How can you hear the radio? That can't be the radio. There's no B+ on it yet. It's just some noise of some sort. Not sure what. Okay, B+ coming up here. aiming for 150. Oh, okay. 150. Now, I think I'm on the broadcast band. Yeah. Good. Turn the volume down. So if I can just knock that noise down a little bit here. And we can still hear the radio, I think. I have to turn it up full now. So I'm not quite sure where the noise is coming from. That noise. But we're going to have to ignore it. Okay, so we want to look for the oscillator. So I said the oscillator is always on this capacitor, so I'm going to hook up on one side here. You can definitely hear a difference. What happened? Trying to get my scope to trigger here. Probably won't. Okay, we don't need it to trigger anyway. And you can see the size of the signal there. And we're doing that on one side of this capacitor here. And I'm going to move the lead to the other side. My guess would be it should look the same. So there I see how many divisions there? 1, 2, 3 and a half. And this is 1, 2 and a half. 3. This is 3. So slightly less where I have it connected now. Okay, we'll change bands. There's a drop in the size of it here. On the other side of the capacitor. Now that's just a little over 2 divisions, and this side is a little over 2 divisions. No, this is closer to 2. So again, slightly lower on the side I'm connected to right now. So one more band. Hey, what happened? So I can see what's going on. When I attach the scope, the oscillator disappears. So there's some kind of tuning effect there. On with the scope. Gone. There. Gone. Suggesting to me that although it's operating, it's very, very weak. And then we go to the next band. And now we're done. There is no oscillator there to affect or anything. It's just not going. Well, hooking up the ground wire to my scope is causing all that noise. So you gotta remember that this radio is isolated from the power system. So hooking up a ground to it from a piece of ground equipment makes a big difference in the radio's operation, I guess you could say. Maybe that's why the noise becomes apparent then. So what did we learn? So we learned a little stronger on one side of that capacitor than the other. As you go up in frequency, it gets weaker and weaker every time, until finally it just can't oscillate. On the third band, oscillate without the equipment, put on the test equipment, oscillation's gone. It's just really, really weak as an oscillator. So I'm gonna move that yellow wire. Let's go back to a functioning band, one that can tolerate the scope. And what the heck was I gonna do? I totally forgot what I was gonna do. Let's tune. Okay, I don't know what to do. Let's tune the radio and just watch and see if the oscillator frequency output changes. Not a bit. Not a bit. Nothing going on there. Oh yeah, I was going to move the yellow wire. That's what I was going to do. Right. Okay, I have to grab it with a big metal pair of pliers here. And wiggle the yellow wire and watch what's going on the big hunk of metal going in here. So I'm trying to pull the wire away from, I can't do it from here. I'm trying to pull the wire away from the steel with this great big hunk of metal. Maybe this is something else. Do it with a lighter pair of pliers. No, I'm not going to do it with that. I'm going to hook it and pull it away. Okay, hook the wire, pull it away, and watch what happens on that scope. Expecting nothing. Just expect nothing to happen. Okay, hook the wire. Oh boy, I'm set up for a shock here. If I put my hand on that, I get pulling on the wire. I'm not pulling the wire anywhere. Very hard to get a hold of it. Pull it here. Pull it here. Nothing. That's a crazy idea. So the signal should be on here all the time, no matter what band we're on. Why don't we hook up right on here and see what happens? Let's see. Maybe it is band dependent. I didn't read something there. Okay, so we're on the top dead band, next dead band. I'm watching the scope, so I go. There's never anything appearing here. I may have found the problem. Make the scope more sensitive. There we are. So all we're finding out is, yeah, of course, when it's not oscillating, there's no oscillating signal in this tickler coil. It's there for the others. Is this tickler coil supposed to be tickling this guy? Wait. Start at top. Next. That's this coil. How can I interfere with the tickler like that? Stick a piece of metal in there. Stick a piece of tin. Rounded metal. This is a crazy thing, but I'm at the point of just doing crazy stuff. So here's a piece of metal. This is just craziness. This is nonsense. So that's just affecting the coil and holding it in here. Same with my finger. The idea is I'm interfering with the tickler signal coming from here up to here, and if I interfere with it, it'll change the output. They don't see any of that. It's nonsense. Nonsense. It's nonsense, Jim. We're not getting anywhere here. We did find the signal was slightly lower when it crossed this capacitor here. One side a bit higher, then lower. Could it be switched though? Switch not making contact. It's just so unlikely. But what else have I got to go on? Okay, so we're going to look into that switch very closely now. What about it? it's operating now. I've got to be a little careful. Focus is right up close. Okay, let's get some light in here. Change the focus. I think it's a little too close. Or I'll have to turn the set off. Don't need the set on for this. In fact, I can just kill the high voltage. Really don't have to worry too much about the heater voltage. I'll leave that on. And we'll turn the volume right down here. And you can hear very clearly when I scream that way. Okay, so we're looking at this switch. We're wondering, so what is being switched in here exactly? So it's these coils that I'm having trouble with. So it's got to be the switching from these coils. So we'll examine this part of the switch. Okay, so I'm going to rotate the switch here and watch it operate. That's a limit. So this would be the broadcast band. It's the last working band, non-working band. Oh, okay, so that came into view there. So I'm looking, I'll try to put it dead center of the screen. I'm looking at that copper curved piece there. It looks like a contact that something should slide under. And when it does, you should see it lift a bit. I didn't see anything. Oh, oh. Something break off in here and disappear. Look at the upper part here. Now this is switching other coils. Some ugly looking stuff there. So okay, so you can see now you can see how the contacts work. They're like pinchers, pinching on the rotating centerpiece. Ooh, what's that big thing coming in there? So this is broadcast band. Next band. So there's quite a scrape mark on that part that's moving there. And the scrape mark only goes part way across. Does that come from the very last position? That one, right there. So these contacts are always in contact. Why do they even need to be there? One of them looks like it's bent a bit. Wait a minute. This is on the wrong side of the switch. Oh, they do come out of contact. Oh, they don't. Wait a minute. I just can't quite get the image right. You know, maybe I gotta. Guess I'm gonna put this camera onto something, a more stable platform here. Just gonna bear with me while I rush this into place. Maybe if I'm not shaking so much. Get right in the right spot here. Okay, now you have to bear with me. I gotta change the focus on the camera. It's gonna take a moment here. Okay, there we go. Now we gotta really soup up the lighting in here. Get my little tiny spotlight in there. You know what? It's not going to add enough light. Okay. Little tiny spotlight, too tiny. Okay, let's use this one here. See if this can add to the situation. Oh, just banged the microphone. Sorry about that. I have a new light. Okay, now what do we see at this point? Let's see much of anything. So there's that big piece, and it slides between the fingers that are gripping inside. That's kind of weird. Is that supposed to get through there? I guess it doesn't matter if it makes a contact. Now wait. So there's a contact coming and going. This is AM, next band, dead band, dead band. But this is the wrong part of the switch. Let's go back down to the part where you're switching. So it looks like a series of contacts, but I think it's really all the actions on the other side of the switch, I really think, in this case. Okay, let's watch this switch go. You can see it making positive contact with every contactor. There's just nothing going on here that would suggest there's a problem. You can see through it to the other side. You can see the switch moving on the other side, into the last spot there. Let me just change the focus a wee bit so we can see that just a touch better, but I have the feeling that you can see the clips moving there too, so it just can't be anything wrong with this switch. Okay, and that's been my experience with all kinds of radios. These switches are generally quite reliable. That's been my experience. Wow. Wow. What to do here? What to do? So, you know, my thinking is the problem here is in the feedback circuit that should trigger the oscillations, and that the feedback is being interfered with by something which is depleting it, weakening it, not allowing the feedback to get to where it needs to get to. Let's take a close look at how this works on the schematic. See if we can figure something out from there. Here's the oscillator here. So let's see, so the oscillations are coming out on this wire from this will be the cathode grounded through a capacitor. The switch is shown in the broadcast position, I believe. So by the time you move this switch all the way up to the last two bands, this would be 1 click, 2 clicks, 3 clicks. The 4th click is somewhere out here. How's that work? 1, 2, 3. I guess it just is not connecting. But you see, these are following along. So in fact, you're collecting these into the circuit. This one's out to start, comes in right away with this additional fanciness here. So I would say that capacitor, certainly all the signal passes through the capacitor. This resistor, all the signal passes across this resistor. Looks like 33K here. I've checked all these things. They've all checked out okay, but maybe my checking has been false. This is an attempt to silence the screen voltage, silence or smooth it out so there's no signals here. How big is that? Looks like 0.05 is what it looks like. And this is the one that I resoldered to the chassis. So the oscillatory circuit must be between the grid and the plate somehow. So here's the grid. You know what? This is the tickler coil here. I'm trying to read these little things that are written there. Written there. Again, right? It's got the band number, the meter number there, but I can't quite read it. So you know, this is the broadcast, and then up. These last two don't work. Oh my gosh. Could it just be some alignment issue? Is there something you align related to the oscillator? There's a whole pile of instructions down here on making the automatic frequency control work properly. And this is a fairly detailed explanation of how it operates. I don't quite follow it. But on a high level, what they're doing here is they're using this tube, the oscillator control tube, to look like a varying inductance. And then they're applying that inductance across the oscillator circuit in the oscillator tube, fooling the oscillator into thinking the radio's being tuned a bit. Actually, it's really what's kind of fooling it into. This is all designed to move the oscillator about 5 to 10 kilohertz one way or the other, depending upon an error signal that's developed right in here. The error signal is applied to the grid here, I believe. And ultimately the output goes to the oscillator grid through this. I think this only operates on broadcast. I think I read that somewhere. That it only operates on broadcast. You know, maybe I've been a little bit foolish here. Look what I've done. Look what I've done. So this is the incoming B+ line. And I decided just to connect it here. There's all kinds of places I can connect it, but I've connected it here. And there's a warning that when you hook up equipment to this radio, you may affect the oscillator. And this radio, I've never operated it with its real power supply here. I don't have the real speaker for it, so I can't do that. Could it be as simple as I put this in a spot where it's just too sensitive? You need to be feeding it in from some more distant location. Doesn't make an awful lot of sense to me. So one spot is here. You know, anywhere this wire is going. Another spot I could do it right up here. Way up here. Okay, so this is no voltage on here right now. So we'll feed in the B+ in a different location. We'll feed it in up here. Put this on the ground. Up here. Feeding it in here. Grounding there. No more wires hanging off the oscillator. Better put our monitor. I was going to put it down. I'd be just doing the same mistake, wouldn't it? So we can monitor almost anywhere these red wires go. Okay, we'll get on there. Now how do we know when the oscillator comes on? We're just going to have to try to if the oscillator works, we just have to kind of recognize that the oscillator is working by tuning the radio. That should be okay. Still have the scope here, we can fool if it does actually seem to work, to know. Okay, so this meter's ready to measure the B+. We're ready to hit it with the heaters first. Give it a moment. $110 volts. Okay, I gotta put on the headphones. Volume. Got too many volume controls here. Okay, B+ coming up. $140 volts. What happened? What's happened? What's happened? Band. We're on a dead band. Yeah. Yeah. The reason I stopped, the reason I'm not doing it is I can't remember what I was going to do. That didn't take long. Oh yeah, that's right. I'm trying to operate with this. Yeah, I've been in here too much of this today already. It's afternoon. Okay, so we want to now listen. Broadcast. This doesn't even seem so good. Oh my gosh, it's getting worse. Nothing? Almost nothing there. We're going downhill. What happened there? Why can I not hear the oscillator come and go? So I'm seeing it on the scope there, but I'm not hearing any effect on it. The band. So these all sound the same now. Top band, next band. This one shows an oscillator, but I don't hear it right. You know why? I think the oscillator is really weak. Is that so? If I go down a band, it's like gigantic. It doesn't get gigantic. We have broadcast band working, next band working. Now we got 3 dead bands. The other way. 3 dead bands. This up, knocking down the signal a whole bunch, but you can never tell because you can tell now because the radio won't work with that level of signal. Oh my gosh, this is the broadcast band. gotta assume that that is depleted signal, depleted by my scope. What am I on here? I'm on times 10. You have to monitor this without depleting it. I think I know how I can do that. Well, I think I may have found something here of interest. So there's two 33 K ohm resistors. There's one here. There's another one right here. So right now I've got my ohm meter connected across this one up here. It's supposed to be 33. You can see it's reading 42. It's gone high. Let's check this one. Check my meter. That would make this to be open circuit. I think that resistor is open circuit. Now, I don't know how that could be. I've tested it at least twice before and passed over it. Why now it appears to me to be open circuit, I don't know. If you change the band, it doesn't do anything to the result here. That guy. That guy could be the whole problem. Right there. Okay, well, I've replaced the two resistors here. One of them was way out, the other one only a little bit out. Here's the new resistors. One here and one up here. Good. We're good to go. Okay, let's put on some B+. See what we get. Set here, I think. Okay. B+ coming. Should show up here. Don't know what that funny sound was. Whoa. Oh, something very different is happening. Whoa. Hold on a second. So it really appears I have only 10 volts on this radio. A B+. This just isn't possible, is it? Is it really operating? Well, it seems to be tuning. Okay. Maybe this is the problem. Oh. 10 volts. Okay. Let's go a little higher. Unbelievable. Okay, the volume turned up fairly high. The part that's so different is the current meter on the supply here is sitting on 0. It used to be going up to 25 milliamps. That's a surprising change from just doing these resistors and actually reducing. There's something funny going on here. A little higher on the B+. You know what? The current is showing up now. Voltmeter is connected right where the supply comes in, so it's really reading the supply. But the supply, there's something funny going on here. Something's not right. The supply itself is saying there's 160 volts on it. It's operating like there's 160. What's going on here? Why are you doing this? How can this be? This really can't even be possible. My battery's gone low. I wonder if that's what's happened. Yeah, I get 145. I don't understand. Okay, it's obviously 150 volts. Now, let's get to the real business at hand, which is making these things work. Let's turn it up. Broadcast. This is the broadcast band. Okay, no question it's working. Next band. Hard to say. You can hear my soldering iron. Wow, it's not terribly it's not very reassuring. Next band. Okay, it's tuning something. Doesn't seem right though, but something happening there. Next band. Silence. Silence again. Yeah, don't laugh at me. My soldering iron thinks this is hilarious. And the last band. Wow, I really thought those were going to do it. But they didn't. Well, I kind of made a mistake of testing these resistors because I'm just so curious about what's going on. So watch my meter there. These are supposed to be 39 ohm resistors. Yeah, and the other one, look at that. They're both exactly correct. So there's nothing wrong with these resistors. Seems to be a lot wrong with me. That's what appears to be the case.